Yeah, it's sort of questionable. All right, well, we'll go with that anyway. So we'll do crude measurements here. So it looks like a focal length of 14 centimeters. It's a converging lens, so positive 14 centimeters. And in this situation right here, I had the object within the focal length. So, as I'm looking at the second button there, that it appears bigger, right?
Yeah.
Okay. And yeah, it definitely. It appears bigger than it did. And the distance, I would say it does look farther away. It's difficult to tell because it is bigger. I think there's some aspect of our brains going, it's bigger, so it must be closer. Question is John buying it?
Well, it just looks bigger to me, even when it's like that, it still looks bigger than what it is.
But you're looking through another prism,
That's
than
what I was
glasses.
thinking, you're looking through
Oh.
your glasses,
Good
relative
point.
without.
Now I'm saying, maybe if I get closer.
Well, even if he takes the glasses off, he still has the lens in his eye.
Mm.
Take your eye out.
Straight up to the retina.
If I make this closer to me, it looks further away, but it never looks farther than it is.
Okay.
But I'll take your word for it. Cause I can't really demonstrate it, or it's kinda hard to demonstrate.
Yeah, alright, so. Upside down, getting bigger as it gets closer.
If you put it closer to your eye, he looks farther away, but it doesn't look like he's,
Right up
It's
on.
all blurry.
yeah, it doesn't look like he's farther away than he actually is. Maybe, that might not be the right lens to demonstrate that.
Yeah, I was trying to remember what lenses we have. I wonder if there's still some in the other room. Alright, I'm gonna have to, see if I can track them down later.
Let's move on.
Yeah. Alright. So as implied, especially at that point, when I talked about its converging lens, I made the focal length positive. Diverging lenses make the light spread apart, and I have a focal length that's negative in terms of the math. So let's just run through one diverging lens, and then let's get to the system of lenses. So if I diverging lens, so the focal length is negative, so if I said that the focal point is 10 centimeters away from a diverging lens, you should interpret that as diverging lens, negative, 10 centimeters away. And I have an object that is, we'll just say 30 centimeters. So here's a diverging lens. Now it's easy to tell some diverging lenses, it's concave on both sides. That's going to be a diverging lens. This is concave, diverging, this is convex on both sides. This is a converging lens. And I'm sure I got some of those words backwards. It's the ones where you have one that's convex and the other one's concave that potentially gets an issue over which one it is. Then you have to use the lens maker's formula. So I put the object, I think I said 30 centimeters away. Let's do the math and then we'll do the drawing. So 1/30 plus 1/q is 1/-10. 1/q is equal to -1/10 minus 1/30. Q is -7.5. Somebody will correct me or confirm.
You're right. 7.5.
Oh, wait a second. So its focal length was -10 centimeters, so -10 centimeters. An image that was 30 centimeters away. So a little bit off camera there. And we're gonna go through the process. Now, it's not gonna be exactly the same as a converging lens. As the light comes in, it's gonna hit here, but the diverging lens means the light wants to go away from the center. So instead of going through this focal point for a converging lens, it goes away from the nearer focal point. So the light's gonna shoot off like that, and that is better. So light that comes in, will hit, and then go away from the focal point. Light that goes through the center will just go through the center. I'm going to draw that somewhat straight. And your brain is going to process it. If I've got a lens here in my eye and I'm looking at it from over here, the light's coming in, it's diverging, and my brain processes it, traces it back, and it puts the image here. Q was a negative value. So my magnification will be negative 7.5 over -10, over 7.5 over 30, -q over p. So I end up with a positive value, and basically it's 0.25. The fact that it's positive tells me that the object is upright, and it's 1/4 the size of the original. Q is negative, tells me it's on the virtual side of the lens. Since light goes through a lens, a negative Q means it's on the same side as the object. And that's about it. Questions before we do the multiple lens system?
Are we still doing master sets?
I'm sort of thinking towards no. We probably should figure that part out. Considering we've got, I guess, 4 days left
4 days.
after this. Seems like there should be a quiz somewhere in there. All right, how about this? For the quiz, I'm gonna give you, this will be on Tuesday. I'm just tossing that out for now. I'm gonna give you a focal length of, converging and diverging mirror and a converging and diverging lens. Tell you where the object is, you tell me where the image is, and then you draw it out.
Ooh, you had me, and then he said draw it out.
Yeah, I was thinking the same thing.
Suppose I gave you graph paper.
I'll try my best.
Well, at least if you work through the math, then you know where the answer is supposed to be, so you do the math right. It's the same equation for all of them, it's just a matter of interpreting the P and Q and F. And there are problems in the book that are similar to this, so it's not like, I mean, you can still look at the book to get guidance on it.
Right, so you said converging and diverging mirror, converging and diverging lens.
Yep. Thus. So that'd be 6. So let the lens, mirror. And then positive and negative focal lengths. So basically 4 problems. I'll tell you right now, there's gonna be a test question very similar to this.
Remind me, is the P 1/P plus 1/Q equals 1 over F, they're the same on both of the mirrors and
Yep.
lenses? Okay.
And Q
So
and
what
P
F?
and F all, well, F doesn't mean the same thing, does it? And one means focal length and one means focal length, image.
F is the focal length for lens or mirror.
Okay.
If the mirror causes the light, either one, mirror or lens, if it causes the light to come together, mirror, it's gonna reflect back together, and lens, it's going to go through and come together, then your focal length is positive.
Okay, well, I was just asking because and maybe I'm wrong, somewhere in there you said F was focal image.
I made the reference to focal point and focal length, and I've incorrectly used them interchangeably. Focal point is actually a location that is the focal length away from the lens or mirror.
Okay.
So technically, the focal length is that distance, the focal point is that spot in space.
But F represents both of them, correct?
Yeah, it technically is that length, F represents that.
Are we still taking the final test next Thursday?
Yes.
Okay. Are we doing a lab tomorrow?
Yeah, still lab tomorrow.
Okay.
When you gonna post it?
It'll be sometime this afternoon. I'll
Okay.
get home probably somewhere before 5, and so after my nap. All right. The clock now says it's time to go.
All right, see you tomorrow.
Mañana. And I'm gonna see what hot dogs are left. If nothing else, I'll feed them to the dogs.
Do some problems. Open them.
Walking out, getting to this off.
Yeah.